The average one-way fare from Pittsburgh to Washington, D.C. is $236. A random sample of 20 one-way fares during a particular month had a mean of $214 with a standard deviation of $43. At alpha equal to 0.01, is there sufficient evidence to conclude a difference from the stated mean? The question is there sufficient evidence to conclude a difference? If we are going to conclude a difference, it would be because the sample mean was either significantly less or significantly greater than 236. So that means that we would have a two-tailed test. With the two-tailed test, our null hypothesis would be that the mean is equal to 236, and our alternative hypothesis would be that the mean is not equal to 236. And this would be a two-tailed test. Part 2 says find the critical values. Enter the answers in ascending order and rounded to 3 decimal places. We'll find the critical values by looking at Table F, the t-distribution table. What we will need to know is the degrees of freedom and the level of significance. Our sample size is 20 and alpha is 0.01. So we have 19 degrees of freedom, a two-tailed test where alpha is 0.01, which leads us then to critical values of minus 2.861 and positive 2.861. We are now to compute the t-test value. We're going to round the t-score to 3 decimal places. We can do that using the TI-83 or 84 calculator by pressing Stat, going over to Tests. Number 2 is t-test. We are going to enter some stats. We don't have a list that has all of the data values in it, all 20 data values. What we have are statistics that have already been calculated. Our hypothesized mean is 236. The sample mean is 214. The sample standard deviation is 43. The sample size is 20. We have a two-tailed test, so we'll make sure that not equals is selected here for the alternative hypothesis, and then we'll go down and hit calculate. We find a t-test value of minus 2.288. Note that this value is not less than minus 2.861. It's between minus 2.861 and 2.861, so it does not land in the rejection region. So now we need to make the decision. Since it does not land in the rejection region, we do not reject the null hypothesis. Now we are to summarize the results. There is not enough evidence to support that there is a difference from the stated mean. Since we did not land in the rejection region, and since we do not reject the null hypothesis, let's go back and look at what our null hypothesis is. The null hypothesis is that the mean is equal to 236. We were asked, is there sufficient evidence to conclude that there is a difference? And since we are not going to reject this, then we should say that there is not enough evidence to support a difference. Next, we are to use the sample statistics to construct a 99% confidence interval for the true mean one-way airfare from Pittsburgh to Washington, D.C. and round the answer to 2 decimal places. We can do that using the TI-83 or 84 calculator by pressing Stat, going over to Tests, and then pressing 8 for t-interval. Again, we're going to use statistics, not a list of data, and all of the values are already here. The thing that we need to do is type in our confidence level. Since we had a two-tailed test with an alpha of 0.01 that would have been split out into the two tails, then our confidence level should be 0.99. That's the area that would be between those critical values. Go down and hit calculate, and our interval endpoints are 186.49 and 241.51. Do they support or contradict one another? Now, looking at this interval, we find that this hypothesized value of 236 is contained inside of this interval. And this interval interpretation would be that we are 99% confident that the actual population mean is between these two values. Well, since 236 is between these two values, then we have no reason to contradict that the mean is equal to 236. They support one another because 236 is inside the interval, not implying a difference.